Electric field is a vector quantity. Its value, its sign and magnitude all changes with distance. Due to point charge, let us take the electric field at a distance x once more. This we did before. Electric field is given by kq by x square, that you know. And we want to plot this graph. When we plot the graph, we will take the distance along x-axis and electric field along y-axis. So for your convenience, I am taking the charge at the origin. Then along x-axis, along positive x-axis, electric field will be directed towards right, because at any point to consider a positive charge or a vanishingly small test charge will experience force in what direction? It will experience force along positive x-axis. So electric field is directed this manner along positive x-axis. Now what we are going to do, we will plot this value of electric field with distance x from origin. This is the origin. Two-dimensional coordinate system we'll draw, and then we'll find how this graph can be plotted. This is positive y-axis. Electric field either will be along positive y-axis or will be along negative y-axis. This is positive x-axis, this is negative x-axis. Now before we plot, we need to know the nature of the graph of a function where e is proportional to 1 by x square. Even with this example, we discuss the value of e for x equal to 0 or tending to 0, whatever you say, e is infinity. Okay? So at origin, the value of electric field is infinite. And for x tending to infinity, e is tending to be 0. And for x equal to 1, points are like this. Here it is 1, 2, 3 meter away from the charge. So for x equal to 1, the electric field is given by, if you use this relation, that is k into q. For x equal to 2, E2 going to be equal to kq by 4. And for x equal to 3, E3 is going to be kq by 9. So by keeping this in mind that when x equal to 0 or tending to 0, e infinity, and when x tending to infinity, e tending to 0, and value gradually decreases. So we are starting like this and continuing this manner. Somewhere at infinity, this will meet the curve. See, here the value is e into q. Here the k into q. Here the value is kq by 4. Here the value is kq by 9, kq by 16, 25. It is gradually reducing. When x tending to infinity, e will be tending to 0. So the graph of e equal to kq by x square will be like this, as e proportional to 1 by x square. And e on the right side of origin directed towards right, so graph will be like this. But if you consider this region on the left side of origin, then the direction of e will be like this. E is directed along negative x-axis. Its value goes on decreasing the same manner. But the thing is that if you have decided this direction going to be positive, I mean along positive x-axis electric field, distance along x-axis gradually increases. Electric field value has positive values but gradually decreasing. So it will be like this. But here electric field is directed negative direction. So if you have planned to plot along y-axis only, this time this E going to be negative quantity and its value will be decreasing the way it is decreasing here. So electric field with distance will continue this manner. Okay. So same graph will be repeated in the third quadrant. So this time due to a single point charge, electric field will be radially outward. The graph will lie in the first quadrant or in the third quadrant. Here electric field you have taken along y-axis. Here it is positive but decreasing value. Here it is negative, strength is decreasing. So that's why graph will be like this. Okay. Because here also when you take x tending to 0 minus, it is tending to minus infinity. Then value goes on changing this. So electric field due to positive point charge will be like this only. This is the graph. Let us do it for a charge minus q. Keep a charge minus q at the origin and then check how electric field changes with distance. This time we are taking the charge minus q. This charge minus q taken at the origin, same manner we are taking x-axis, y-axis. Electric field always will be along y-axis. Okay. And electric field magnitude, that quantity, this is never changing. That E equal to kq by x square. But this time q is negative. So how to find the direction? I told you towards right, if it arises, then it's a positive quantity. And if it arises towards left, electric field directed to this is negative x-axis. We take as x dash. If electric field directed this way, it's a negative quantity. Positive quantity and this one negative quantity. Now, if you keep a positive charge here, due to this minus q, it will experience force towards left. So, electric field directed towards left. Towards left means it's a negative quantity. Now, E always taken along y-axis or negative y-axis. This time it will be along negative y-axis. Variation will be as before. So the graph of electric field versus distance will be like this only. Same graph, but this time it lies in fourth quadrant. First, for x greater than 0, electric field is negative because it is directed towards left. And here, if you take a point here at this point, electric field will be directed towards right. So if this electric field directed towards right, it's a positive quantity. So how do you get the graph here? Same graph will be repeated in this quadrant. Okay. Same graph, that E equal to kq by x square, but this time it is directed towards right, so it is positive quantity. And here it is directed towards left, that's why negative quantity. That's why graph lies here below the origin along negative y-axis. Here it is above the origin along positive y-axis. So we will keep this concept in mind to get the graph in those cases which I have told you. So let us make the sign convention correctly first, that when you are taking electric field directed this way, the field will be plotting along positive y-axis. E directed this manner, field will be along positive y-axis. Okay, this will be along positive y-axis. If E is positive, if E greater than 0, or if E directed towards right. If E directed towards left, then what will do? This time E is directed towards left. So that graph you have to plot, that electric field will be negative quantity, that you have to plot along negative y-axis, E less than 0. Okay? So we will be plotting along negative y-axis. This is negative y-axis. This one positive y-axis. Clear? Here electric field less than 0, that's why negative y-axis. Electric field greater than 0, that's why positive y-axis. Now, suppose there are two charges given this manner. Like one charge is plus Q, another one plus Q. How to plot the electric field strength? Just I remind you again that electric field is E equal to kq by x square, whether positive or negative, depending on that it will be directed along positive y-axis or negative y-axis. This time when you take these two charges side by side, plus q and plus q, then we will observe that this distance along positive x-axis, this region, this along positive x-axis will divide the whole region of space into three regions. Which three regions? This is one region in between. The case we have taken two positive charges side by side, plus q plus q. This is first region. This is second region. This one is the third region. How electric field changes with distance, that we are going to find. First we consider this region. If we take this region, plus Q will exert force on vanishingly small test charge towards right. Electric field will be towards right. This one also repelling it towards right. So field will be directed towards right. Now question arises, how can we expect similar graph here? Because two charges are there. Due to single charge, it will be like this. There is an advantage of inverse square law. Okay? The electric force or electric field obey the law of inverse square. Inverse square law graph is like this. Now you can say that distance from here, if you take x, then distance between these two charges be a. Then electric field at this point, the expression I am just writing something like this. If the distance is x, it will be kq by x square plus electric field with this, that is kq by a plus x whole square. So you all can observe that x increasing, the value of E is decreasing gradually. So graph nature will not change. It obeys the law of inverse square. So the graph nature will not change, and this region you have seen that electric field directed towards right. So the graph is going to be like this only, which you have seen before. Okay. What about the electric field at this point? At this point, plus Q will repel the vanishing charge, vanishingly small charge this way, and this Q will repel this way. But this region is close to this, so its effect will be more on 1 coulomb charge or vanishingly small test charge you place here. It will push it towards left. So electric field here directed towards left. It's a negative quantity, isn't it? At this point, it is midway between these two. In numerical example, I have discussed that if it lies at midway between these two charges, electric field strength going to be equal to 0. This is a null point here. E equal to 0. Why 0? Because this distance a by 2, this is a by 2. This one will push it towards right. and this one also will push it towards left. These two forces are equal and opposite because both charges Q and Q over there. Definitely I will discuss the case when charges are of different magnitude. But right now, same magnitude we have taken, electric field will be 0 here. At this point, what will happen? At this point, plus Q will push it. Electric field, so this region directed towards left. So electric field E is a negative quantity here. It was positive, we have taken this manner. At this region, it is close to plus Q, electric field will be directed towards right. Although this plus Q is repelling it towards left. So electric field E is positive here. What will happen at this point? Plus Q will repel. This plus Q also will repel. So E is again negative. Isn't it? Now if E is positive, graph you know. If E is negative, graph you know. If E positive, at this point it will be 0. So the value gradually decrease, will become 0 at this point. Okay? And here electric field is negative. That's why the graph will be similar to before. It is mirror image of this thing, or third quadrant, it is, don't say mirror image, third quadrant is going to be repeated. This graph, as E is a negative quantity, the graph will be like this. Okay? Electric field is 0 here, you got a neutral point over there. And the field, I mean that graph, E versus X graph will be oriented this way. Now what will happen at this point? At this point again E is negative. E negative, you don't have any problem. This graph will be repeated here in the third quadrant. No, don't say third quadrant, in this region. Okay, because both are pushing it towards left. So electric field will be in negative direction. You must take it this way. So this is done. Due to a point charge due to plus Q, another plus Q charge, electric field will be directed. I mean graph will be like this. Now what will happen if two negative charges are there? Let me discuss for two negative charges kept side by side. Minus Q, and imagine the distance between these two charges as given before is equal to A. Okay, so this portion A by 2, this is A by 2. Both the charges are negative. I told you when two negative charges are taken. What will happen? Electric field. Again you start plotting it along x-axis, distance along y-axis, the strength of electric field. E along y-axis, x along x-axis. And here at this point also we will observe this direction, this one and this one. Okay. Now if we want to find electric field, these are both negative charges. I remind you again, no positive charge is there. This is negative charge, minus Q. This is also minus Q. Okay, they are taken at these 2 points A and B. At this point, what is the direction of electric field? If you take a point here, what is the direction of electric field? Minus Q will attract, this minus Q also will attract. Electric field will be strong directed this way. Okay, and corresponding graph, as E directed towards left, it's a negative quantity. So the graph of this function is like this only. Okay, so this is electric field graph when you consider distance away from this charge minus Q. At this point, what is the direction of electric field? Minus Q will attract, this minus Q also will attract. But this one closed, so force will be there towards right. Electric field will be there directed right. If electric field directed right, then what kind of graph expect? And minus q due to the same logic, there is a point here which can be referred as neutral point. Electric field will be 0 at this point. Okay? Electric field is 0 at this point because minus q both will this minus q will repel vanishingly small charge towards it, and this also will repel. Okay? So electric field at O will be equal to 0. Neutral point again you get here. But before it, after this point, what will happen? This minus q will attract plus q charge. Then again it is going to be negative. Got it? Electric field will be directed at this point. No, minus q will attract. It is directed this way. For this, it will attract, but its effect will be more. Charge at this point will have more effect. So electric field will be directed this way. So what kind of graph you again expect over there? Electric field directed towards left, it's a negative quantity. Here net electric field is directed towards right, E positive. E positive means, and at this point it is 0. So the graph will be like this. And here, this is a repetition of this graph about negative y-axis. It will be like this. Alright? And what will happen if you take a point on left side of minus q charge? If I keep a unique positive charge here, that will experience force towards right. Wherever you keep. If a vanishingly small test charge taken or 1 coulomb charge taken, the force experienced by is the strength of electric field. So this field will be directed in what direction? This is positive. So it will be like previous graphs. About 2 y-axis. I did a mistake over there. It did not be so close. Just a minute. It will be like this. Alright? So the graph of electric field will lie in 4th and 2nd quadrant, and here it is like this. We get another null point here. In this case, electric field is 0 there. That's why. Now if we keep a positive charge and a negative charge, what will be the strength of electric field? This is plus q and this is minus q. How to plot the graph of E versus X in this case? Let us draw it again, that x-axis direction. This is negative y-axis. Positive x. Direction plays a very important role here. Graph just repetition of that. Okay? It's just repetition of that thing. So what you'll do here, you'll consider again electric field the way you have taken before. That is along y-axis, along x-axis. Okay? So what will happen at this point? This is plus, this is minus. It will be attracted this way. Am I correct? So what will happen to the electric field over there? That electric field will be negative and directed this way. This I am telling you repeatedly. Okay? So it is directed along negative x-axis. That's why graph is like this. What will happen at a point in between? Is its value 0 at the midpoint? No. Its value will gradually decrease. And this plus q will create electric field which is directed towards right. This one minus q directed towards left. But here it is close to the point plus q, so electric field will be directed this way. At this point what will happen? Minus q will attract, plus q will repel, minus q has greater action. So electric field at this point will be a positive quantity, and it will be directed towards right. What will happen at this point? if you gradually decrease the distance, this electric field decreases. Gradually, the value of electric field decreases, but it will never be equal to 0. We have seen that electric field calculation if a charge plus q and minus q given here. Strength of electric field never 0 on the line segment joining these two charges. So what will be the graph here? At this point I have plotted. At this point it is directed towards right. Due to electric field will be directed towards right. Due to this minus q, because minus q going to dominate. That's why the graph will be like this. But here at this point electric field is not 0. So the graph will be approximately like this. Alright. Here it is the resultant of field created by plus q and minus q. Here the field is positive quantity, that's why it is taking the shape of this. Here it is along negative y-axis, that's why it is taking the shape like this. What will happen on the left side of origin? Left side of this point. At this point, electric field will be directed towards left. So it's a negative quantity. Check once. At this point it was positive. At this point plus q will repel minus q, although attracting it, but it will not get the success because plus q is dominating here. It is dominating here. So electric field will be directed towards left. Towards left, if the electric field is directed, then what will be the graph of electric field? That we have to explain. This is plus q minus q. Plus q makes, so the graph will be like this. Is that clear? Because it is directed along negative x-axis. So its value will go along negative y-axis. It's negative y-axis, not x-axis. Alright? So this is the graph of one positive and one negative charge. Now, the question is, what will be the maximum value at the point a by 2? If we have taken that, what is the maximum value from this distance is a by 2, at a by 2? This is the question. Then you have to go for numerical calculation. And this time it is not maximum value, it will be minimum value. So the graph will be like that. Clear? At this point, at a by 2, it will have the minimum most value, then its value goes on. I hope all of you have understood these simple graphs where electric field versus distance plotted. I leave this topic by discussing another problem on graph. You don't know whether you get plus q minus q always, or like minus q, or like 2 positive, or only 1 positive, 1 negative. Situation may be like this also. How to plot the graph here? We will keep that concept only in our mind. What concept? That along positive x-axis, if electric field is there, it is a positive quantity. Negative y-axis, negative x-axis, it is negative. I mean, if it is directed along negative x-axis, electric field is negative. Now, how to plot the electric field versus distance? Plus q and plus 16q. How to plot the graph here? See, this one plus q, this one plus 16q. Before we plot the graph, we must know the point where the strength of electric field going to be equal to 0. Why? Because at some arbitrary point plus q will repel, this 16q also will repel. So there is a point where the force due to plus q and force due to 16q balance each other. At that time, there will be electric field equal to 0. Let us find it. Distance be x. So this is a minus x. At this point, electric field is what? E equal to 16q by a minus x whole square. It is towards left, negative quantity, plus K will be there obviously. K into Q by 4 pi 0 x square. This time it will be directed. No, this time electric field I have considered 0. Put this thing equal to 0. So 16 by a minus x whole square equal to 1 by x square. Clear? So this is going to be 4x. By taking plus sign, x will be equal to a by 5. At the point a by 5, electric field strength will be 0. Now, let us pay the attention in plotting the graph. I am writing once more 16Q here and charge Q is here, and we are going to plot the graph. Same concept, positive y-axis, negative y-axis, all these are there. At this, similarly, you draw the same thing here. Why I am drawing first? Because my calculation will be perfect. Okay? You also need to make it perfect. So, due to this, when you are going to plot the graph, we have seen that electric field at a distance, if the distance is equal to A, electric field at a distance A by 5 going to vanish. On the right side of plus 16Q, this is dominating charge. So, electric field directed towards right. So, the graph of electric field versus distance will be like this. Clear? Now, what will happen at this point? Electric field directed towards left. Due to this plus Q directed towards right, but 16Q is dominating over there. So, it is directed towards left. Towards left means it will be 0 at this point. At x equal to a by 5, it is 0. And it is along negative x-axis. So, graph will be like this. It will be 0 at this point. Am I clear? At this point, what will happen? 16Q, although repelling it, this plus Q repel towards right. So, and electric field is 0 here. So, the graph will be like this. Is that clear? So, what is happening there? Electric field is 0 at a distance a by 5. Before that, it lies in first quadrant. After that, it goes there. This is third quadrant. This is first quadrant for Q. Now, on left side, what will happen? Both are repelling. Electric field will be directed this way. The graph will be negative. So, it will be like this. Alright? E is positive here, and this distance is just mentioned. It is a by 5 distance. It happens. So, this way, any charge given that taken along x-axis, field is also concerned along x-axis. This is the technique you apply. You will be able to solve all the sums. I promise. Okay? See you again. Thank you.